Hey guys, tonight we're working a problem that some of the TSU students said they were struggling with. So it really boils down to what tools to use when we're performing an integration. So we have the integral of x e to the 2x divided by 2x plus 1 squared, and we're integrating on x, so it's a dx. Now I've listed the tools that we typically use here. And actually, I'm an acronym guy. UTIPPLC is what goes through my mind when I'm trying to understand what tool to use. U would be U sub, T is trig sub, I integration by parts, P is partial fractions, also P is power reduction, L long division, and C is complete the square. So let's start with complete the square. Can I use that here? Probably not. Long division? Probably not. Power reduction? No. Partial fractions? No. Trig sub? Let me skip integration by parts. Trig sub? No. So my only two options I have here are U sub and integration by parts. Now integration by parts, I have 3 parts right now. So, what do I do with that? I don't know. Let me take this from the X world and put it into the U world, the U sub world, and see if I can reduce some things, separate some integrals, and just see what happens. I call it noodling around on it. So let me noodle around on this. Okay, so I'm going to choose U to be 2x plus 1. U equals 2x plus 1. Remember now, my goal is to change all of these x's into something that's U, a function of U. U is 2x plus 1. Du equals the derivative of 2x plus 1 is 2 dx. Derivative of a constant is 0. So dividing 2 on both sides, du divided by 2 equals dx. Okay, I've solved for this term. Now then, I have a 2x here and a 2x. There's 2x here. If I subtract 1 from both sides, u minus 1 equals 2x. Awesome. Okay. Now then, but I have this x, and I'm not going to be able to get rid of it. So if I divide u minus 1 divided by 2, divide both sides by 2, that equals x. Hey. Now you may think, wow, your hair may be catching on fire by now. Hey, just relax. Let's replace x with all of these values of u that we have and see what happens. Okay, x is what? U minus 1 over 2. U minus 1 over 2. Okay? E to the 2x, well 2x is u minus 1. So I have e to the u minus 1. And the 2x plus 1, we said, well that is u, and it's squared. And then, so I've replaced my x, e to the 2x, I've replaced that, and then I have u squared. Dx is what? Du divided by 2. So I have 2 times 2 in the denominator. Let me pull that to the outside. That's 1/4. The integral, I have u squared down here. Now I'm going to distribute this u minus 1 times u. So I have u e to the u minus 1 du. Okay. And I'm going to separate this into 2 integrals. I do this a lot, and the reason I do is so I don't lose this 1/4 times all of this. That's one of my kryptonites. I have many. Okay, integral e to the u minus 1 times this negative 1, it would be e to the u minus 1 over this u squared. I'm going to tell you what, instead of u squared in the denominator, I'm going to pull it up to the numerator. U to the minus 2 e to the u minus 1 du. Okay. Now I have u divided by u squared. Gives me 1 over u, which is u to the minus 1. Right? That's 1 over u. Now then, I've separated this thing out. I have two integrals here that don't look that difficult at all. Let's just take this one, for example, and integrate it by parts. So the two tools we're using are these two right here. So, let's see, where can I put that? di. I have 1/4 on this plus minus, plus minus plus minus. What I'm going to integrate is e to the u minus 1. Okay, and what I'm differentiating is 1/4 u to the minus 1. So 1/4 u to the minus 1. So the derivative of u, 1/4 u to the minus 1, bring down to 1, negative 1, so that's negative 1/4 u to the negative 2. Decrease that by 1. Now you know the integral of e to the u du is e to the u. But since I already have a u here, I need to pick a different value, I think, just to be clear. So I'm going to let t equal u minus 1. dt equals du. So e to the t dt is just e to the t, which t is u minus 1. So the integral of e to the u minus 1 is e to the u minus 1. Now then, something to notice here. Let me draw a line here. These were the integrals that I had earlier. Okay, this one, we said, you multiply the diagonal and then take the integral of a row. The three stops, if you'll recall, when the derivative becomes 0, stop. When what's on the row repeats itself, stop. Or you get a row that you can integrate. So in our case, I can integrate this, but I'm making an observation here. Let me just write this out. What do I have? I have 1/4 u to the negative 1 e to the u minus 1. Negative times positive is a positive, plus 1/4 the integral of u to the negative 2 e to the u minus 1. Okay, that's what this equals. So now you'll notice the other integral we were going to deal with is a negative 1/4 integral u to the minus 2 e to the u minus 1 du. Oh, I have a positive and now a negative of the exact same thing. They just cancel. They're gone. So I don't have to do the integration by parts because it just canceled itself. So this equals 1/4 u to the minus 1, we'll just say u, 1/4 u, e to the u minus 1. Okay, that's e to the u, 2x plus 1, that's 2x plus 1, that's u minus 1, divided by 4 times u, which is 2x plus 1. Okay, a positive 1, minus 1, those cancel. So this becomes my answer plus C. Okay, so the tools, anytime you see a problem, begin asking yourself, what tool is it that I can use to solve that problem? And then just, as I said earlier, noodle around on it. I love to use sub when I can. In this case, it really helps simplify the problem. Also, the DI method by integration by parts, I hope all your teachers allow you to use that. It's just a tabular method allowing you to organize yourself versus the old integration by parts method we all were taught. This is so easy to use. So gives you the same answer, and it helps you keep up with your pluses and minuses throughout a very complex, especially if it repeats. The old method is crazy. Okay. So UTI, PPLC, keep those in mind, understand them, work problems with those, and just figure out what tool to use and then go after it. Okay, why are we doing this? We're not crazy. We're trying to build a better tomorrow, and do that how? Do that through math. Okay, that's all for now, and we'll talk to you next time. Thanks.